for this next example, we're going to take a look at a bit of sentiment analysis of some complaints that have come in for a bit of roadworks that is happening, routine roadworks in our case, in Birmingham on the M2. So we got a workspace that's running in a bunch of CSV files with the complaints, and we're geocoding those to then determine the severity, and then using AI to categorize those, and then also AI in a second transformer to then send back responses to the complainants. So if we have a look at the workspace in here, and I'll just hit run on all of that and get rid of that. And here we're just first of all reading in our complaints and then extracting the postcodes and preparing them for a bit of geocoding so we can find exactly where each complainant lives and where they are coming from, so that we know if they are near our roadworks or if they are living a bit further away as well. In this attribute manager here, we are creating a prompt for generative AI. So if we have a look at this, we are saying we've been given this complaint, tell us about it. So tell us what they're demanding, tell us what the severity of the complaint is. So is it respiratory, sleep deprivation, mental health? What type of complaint is it? So what's it related to? Here's our context, so we're letting them know that we are Eagle Engineering, conducting some higher maintenance on the M6 near Birmingham. There's some dates in there, there's some additional information. So giving AI that context to inform it to help us in the best way possible. Giving it the instructions, and then importantly at the end here, defining our output schema. So we want these three attributes to be outputted from the response from OpenAI.
And so probably what you also notice about that prompt is, unlike maybe you've been watching some of our earlier videos where you just put in a normal sentence or request, this is much more structured as a JSON structure. The reason that has been done in that way is it just makes it a little bit more successful in the way that it responds and a little bit more controlled. So in particular, that output JSON structure, that's really important because it means that we can get a response back that looks like the one that Siobhan is showing on the screen there now. And once you've got it back in JSON, of course, FME can play with it very nicely.
Yeah, absolutely. Nailed it. So we have those three output we defined earlier, back in the exact same order, exactly as we wanted them, exact same casing and everything, so we can extract those really easily with FME. That's what we're doing exactly here. So a bit of string replacing to pass some weird little things that occur within the AI, flattening that JSON and extracting our response. This next part here, as we saw, we geocoded those residence addresses earlier, and here we're just doing a buffer, and then using a spatial filter in here to check whether our residents live within our area, as these three here do, or if they're actually outside our area. Yeah, so in our mind, they're not actually impacted by the roadworks. So in this case, residents who are complaining who aren't near the roadworks will just get a generic response from us. But in the case where we have our three who are near us, we're going to develop a response that's catered to their complaint needs and requests. So we look at that prompt for our second transformer here. This time we're providing additional context and giving it explicit instructions around what we're wanting to have as a response. So we've had some residents complain about overnight works. You're a specialist community relations manager, so giving the AI its role to let it know what it's doing, and want it to make sure our local residents feel listened to and engaged. So you need to craft an upbeat, compassionate response to our complaints. We're telling it it excels in communication, it's friendly but needs to be professional, so giving it all the instructions that we get a nice response to send back to our local residents. So just like that, we can get our response, and we have a nice email that we can send to the locals. So from there, you could just send it straight up to them. You might want to send it to another person in the team just to check what's been crafted. Yeah, just like that. Saving lots of time.
I guess the only other thing to kind of add here is that maybe you might be a little bit concerned that you don't necessarily want to send that somewhat sensitive information to OpenAI, particularly if you haven't gone through any type of auditing previously, and just a review on the safety of using third-party services. You can utilize a locally running a large language model. So we're pleased to say that we created within NVIDIA Tensing a very nice transformer which integrates with a effectively a large language model package container called Olama. So Olama allows you to run large language models locally, and you can interact with those large language models through an API endpoint, except the only difference is that API endpoint is running locally. So the neat thing about this is that you can run an open source large language model locally that will produce some very decent responses back, much in the same way that utilizing OpenAI does. So there's a whole range of open source models out there. There's ones from Microsoft, like the likes of 5.3. There's ones from Meta called Llama, or different Llama models. And there's some very good Chinese ones called QN that equally are excellent. These models, they just exist within your system. They don't go out to the web, but are very powerful in amongst themselves. And if you've got a fairly modern machine, you should have absolutely no trouble running them. They'll just take a little bit longer to process than, say, through the OpenAI API endpoint. And yeah, if you want more information, just have a look at that transformer, the local generative AI caller transformer, which is in the FME hub, and it'll give you a little bit more of an understanding. Cool.